I recording? There we go. Hello, my lovely physical science students. This is going to be, the whole chapter is going to be like this. So all of chapter 20, oops, let me go back. All of chapter 20 is going to be this type of lesson where I present videos to you and we actually do the work in class then. So this is the first start of this kind of video. So after today's lesson, hopefully you can determine how compounds differ from its component elements. So compounds are made up of elements. So hopefully we'll be able to look at the symbols and figure out, is there one element or are there more than one elements to make up that compound? The second thing we're going to look at is to explain what a chemical formula represents. So we'll look at several chemical formulas and try and determine what does each of those have as far as elements involved. The last thing then we'll explain how the electric forces between oppositely charged electrons and protons are essential to forming our compounds. And the last thing is to state a reason that chemical bonding occurs. So first thing that we're going to think about, Statue of Liberty. I would like you just to think for a second of why do you think the Statue of Liberty is green? So when the Statue of Liberty was actually delivered from the French, it was technically in a couple pieces. Very large pieces, of course, and they were very shiny colored. Shiny to the point that the Lady Liberty is actually copper, which is kind of surprising. So then why is she green? A compound has been made. So when we take regular old copper, so when copper joins with oxygen or sulfur, it just depends on what type. Sulfur a lot of time you find in acid rain, and of course since the Statue of Liberty is outside in the element, she is going to get acid rain on her as well as the oxygen. Either one of those compounds that forms is a brand new compound. So a brand new compound results in a brand new color. So we get the color green. So copper sulfate, so this is how we would name something that is a compound. So we would call it copper sulfate. In this case, it's copper joined with sulfur. So as we saw Lady Liberty in the picture, she's not shiny like copper is. And technically sulfur is a very, very bright yellow color. And the Lady Liberty, the Statue of Liberty, is not either one of those things. So when we have a compound, compounds are a completely new substance with new properties. So a completely new substance with completely new properties. One other one that we've talked about with this would be the sodium chloride, which is your normal old table salt. As you guys saw in the video for alkali metals, this is very reactive. Very, very reactive sodium. Chlorine, on the other hand, is a gas that can actually kill you. Not a good thing. But put them together, they are not reactive anymore, nor will it kill you because you eat salt. So this is another example of how we get completely brand new properties out of this brand new substance. So writing chemical formulas then. So a chemical formula tells what elements a compound contains and the exact number of each element. So for example, if I have this particular compound of SiO2, if there is no little number right here, we can assume that it is a 1. So that's where we get 1 atom of silicone. This little 2 behind oxygen only goes towards the oxygen. It doesn't go towards the silicone. So in this case, we have 2 atoms of oxygen. So if we have a subscript is the little numbers behind it. So in the case of the silicone, I added the 1. The other subscript would be the 2. Those are little numbers. Those behind an element tells us how many atoms are present. And just like I wrote the little 1 in, if there is no subscript, assume the number is a 1. So let's try and practice a little bit then. So we're going to write each chemical formula and determine the number of elements and atoms. So for this first one, if you don't have your periodic table handy, now would be a time to do it. If you need to hit the pause button real quick, go grab your periodic table, come back in just a minute. So pause, go get it, come back. So looking at my periodic table then, Mg stands for magnesium. And magnesium, in this case, has no little number behind it, so we're assuming that it's a 1. So there is 1 magnesium. I'll write my next element, so O stands for oxygen. And I have an H for hydrogen, so I'll write all my elements down first. So, parentheses, just like in math class, if you have a number outside, what do you do with it? You're going to distribute it to both of those elements. So the number outside of the parentheses is going to go to both the oxygen to give it 2 and the hydrogen to give it 2 as well. Calcium is our next one, so Ca. And oxygen for our O. In this case, neither one has little numbers behind here, so we can assume that both of them are 1s. Our next element, N, is for nitrogen. And we have an O for oxygen. So in this case, nitrogen does have a 2 behind it. So that 2 only goes to the end because there's no parentheses like there was up top. So nitrogen has 2, O has no number behind it, so we're assuming that it has 1. Our last formula we have here has 3 different elements. So we have a hydrogen and sulfur and oxygen. So those are our 3 separate elements. Now to figure out how many of each do we have. So the 2 behind the hydrogen tells us that there are 2 of those. Only look directly behind the element. Is there a little number right here? There's not, so we're assuming it's a 1. This 4, if there's no parentheses, which there's not in this case, the 4 only goes towards the oxygen. So we'll get to practice these a lot more in class tomorrow. I just wanted to point out a few of these for you. So let's see, why do atoms actually form compounds? Elements want to reach stability when their outermost ring is filled with 8 electrons. That's the key to why things want to bond. They want 8 electrons in their outermost ring. The way they'll do this is they will either gain or lose electrons, causing bonds to form. So just to show you what it looks like when a bond is created, the electrons from one atom are attracted to the positive protons in the middle of the nucleus of the other atom. The electrons of the atom itself are attracted to those positive protons, and so on and so forth. The only thing then that is repelled, sort of keeping these atoms from sucking themselves into each other, is that they have these positively charged middles that the green line indicates that they're going to repel each other. So the forces that hold an atom together are the forces between the electrons and the protons. That magnetism force is going to keep our compounds together. So practicing dot diagrams. So just to review a little bit of how we practice dot diagrams, I sort of put a question on here to kind of get us thinking about how do we determine the number of dots in the outermost ring. So how do you think we do that? So if you said the group number, you would be right. So we want to look at the group number of that element, and we want to draw dots around the object to correspond to the number that's in the group. So first thing, hydrogen. I'll put it right next to hydrogen here. I'll kind of go back and forth. So hydrogen, first thing we do is write the symbol. Hydrogen is in group 1. It gets 1 dot. Carbon, we put a C for the element. We look at the group. Happens to be 14, but remember, we take off the 14 because we can't have more than 8, and so we only get 4. Chlorine, so chlorine we look, happens to be in group 7, so we put 7 dots. Just to remember, sign of the cross, top, bottom, left, right. So top, bottom, left, and that's all I need. My other element here, xenon, so if I look, xenon is all the way on the side as a noble gas. This is going to get a total of 8 electrons. So top, bottom, left, right, and xenon is completely filled with electrons. My last element, calcium, then has the symbol Ca. Calcium is in group number 2, so I get 2 dots, 1 on top and 1 on bottom. So the last thing we're going to do is we're going to practice making dot diagrams and bonding. I've showed you this before, but we're really going to focus on it more during this unit. So the first thing we want to think about when doing dot diagrams and bonding is they're like puzzle pieces. The puzzle pieces are going to fit into each other. So my first goal to do when figuring out if something's going to bond together is I first want to draw their Lewis dot structures. So I'll draw Li, which happens to be in group 1, Cl, which is in group number 7. So originally, when we did this, we said Cl has 1 empty spot. It's going to take this electron from lithium and it's going to put it right there. When you create this line right here, that's making a bond. So this lithium, because it's losing an electron, becomes a +1. This Cl becomes a -1. But notice these two charges are exactly equal and opposite of each other. So this compound, when Li joins with Cl, those two charges are going to balance each other out and become neutral. Hopefully every compound is going to do this. So let's do Mg, which happens to be in group 2, O's, which happen to be in group number 6. So I'll put 2 O's here. All right, so again, this O sorry about this. I had to take a second just to think about this one. This one I put the wrong number in. Get rid of that O so that we can actually get rid of this other O. Sorry about that. All right, so my Mg has 2 dots. My O has 2 spots to fill in. So it doesn't matter, one of the dots will go here and one of the dots over here. So Mg, because it's losing 2 electrons, getting rid of them becomes a +2. And our oxygen, since it gains 2 electrons, will become -2. Again, look at the 2 charges, +2 and -2. Those are going to cancel each other out, and they will become neutral. Very last one then, we have H and F. So 1 electron for H, and there are 7 electrons for F. So again, the 1 electron is going to go right here to make this a -1. My H will become a +1.